Here's an example in how to test a claim about the population mean. Calcium is essential to tree growth. In 1990, the concentration of calcium in precipitation in Shotokawa, New York was 0.11 milligram per liter. A random sample of 8 precipitation dates in 2018 results the following data. Okay, now we're assuming that conditions of the test are met. A normal probability plot suggests the data could come from a population that is normally distributed, which is a requirement here. If your sample size is less than 30, we must make sure that our population is normally distributed, bell-shaped. The box plot does not show any outlier. That is another condition of the test. Does the sample evidence suggest that calcium concentration have changed since 1990? Change means it was the old belief it was 0.11. Change means it's not 0.11 anymore. So the null hypothesis will be mean equals 0.11, and the alternative hypothesis will be mean, not equal to 0.11. And that is the claim. The next step is to run a t-test, which you have to go to t-stats and Statcrunch. I'm going to show you the steps. If you are doing this online, you don't need actually to type in the data into Statcrunch. You can click right here and it's going to open the data set in Statcrunch. So let me show you this. Here you go. Here it is. So we go to stat. Let's just bring this down a little so you can see what we're doing. So go to stat, t-stat. When do you use t and when do you use z? You only use z when he provides you with the population standard deviation. If he doesn't, it's a t-stat. One sample with data. I don't have a summary, I have the actual data. Variable 1. We're testing against 0.11. And what's the alternative sign? Not equal. And if you guys like to see a visual of the p-value, I'm going to show you how to do that. You just scroll down and say p-value plot and hit compute. And then let's go here. And look, the test statistic is 2.027 if I want to round to 3 decimal places. And the p-value is 0.0823. And if you want to see a visual of the p-value, since a two-tailed test, you're going to see half of the p-value on the right and half of the p-value on the left. And watch. You see that's half of 0.08, like about 0.04. And the other half should be on this side. It's not shaded, but it should be. That's what the p-value means when you have a two-tailed test. Okay. So t is 2.027, p-value is 0.023. We need to compare it with alpha. And what is alpha in this problem? He says use alpha equals 0.1. You know, guys, that 0.02823 is less than 0.1. So we need to reject what? The null hypothesis. If you reject the null hypothesis and the claim is in the alternative, you support the claim. You say there is enough evidence at the 10% level of significance to support the claim that you need to write the entire claim. And let me tell you what you should write here. The claim that calcium concentrations have changed since 1990. As simple as that. Okay, so that is the first question. I'm going to do another one now. Okay, here's another example. A credit score is used by credit agencies such as mortgage companies and banks to assess the creditworthiness of individuals. Values range from 300 to 850, with a credit score over 700 considered to be a quality credit risk. According to a survey, the mean credit score is 704.7. A credit analyst wondered whether high-income individuals' income in excess of $100,000 per year had higher credit scores. Higher than what? Than the 704.7. He obtained a random sample of 44, that's N, and found the sample mean, that's X bars, to be 721.5, and the standard deviation to be 80.7, that's S. Conduct the appropriate test to determine if high-income individuals have higher credit scores at the 5% level of significance. Here, because the sample size is more than 30, you don't need to verify the conditions of the test. And if he doesn't ask you, you don't need to do that. So we're going to proceed to stating the null in the alternative. The null should have the equal sign, so mean equals 704.7. And the alternative, we're checking if the scores are higher. So on average, so that's the claim. And now we're going to go to Statcrunch and run the t-test under t-stats and see what the test statistic t and what the p-value are, and then go from there by comparing the p-value with the level of significance, which is 5%. So let me open Statcrunch. So we go to stat, t-stat, one sample with summary. Our sample mean is So sample mean is 721.5, sample standard deviation 80.7, sample size is 44. We're testing against the value 704.7, and we're checking if the mean is greater. And if you want a p-value plot, you want to see the p-value in action, you can select that. The p-value is going to be an area to the right of the test statistic because we have a right tail test greater than. And then let me show you here that you can click compute, and I'll move this to the middle of the screen so you can see the test statistic and the p-value. The test statistic is 1.381 if you round it to 3 decimal places, and the p-value is 0.0872. So that's the step number 2 is the test statistic. Step number 3 is the p-value. And you guys agree with me that this is bigger than alpha, which is 5%. So what's the conclusion is going to be? We're going to fail to reject HO. If p-value is more than alpha, we fail to reject the null hypothesis. And if you fail to reject the null hypothesis, you cannot support the claim. So you state there is not enough evidence at the 5% level of significance to support the claim that high-income individuals have higher credit scores. Excuse me. That concludes the question.